everyone. Good afternoon, good morning, and good evening. My name is Vishvadeep, and I welcome you all on Unacademy Computer Science channel for unlimited learning. Today, I am going to provide you complete data structure revision. Why I have planned this session? Just because there are so many students who are preparing for BAC, HL, PGEE, and multiple more other different types of exams, entrance exams or interviews or whatever. So whoever is preparing for whatever, I am going to give you one single short revision so that you guys can revise or can have a quick revision of entire course from my end so that it can help you in that particular preparation. Before we start, let me introduce myself first. For those members who don't know me, my name is Vishvadeep, working as a channel leader for this channel and as a plus educator also on Unacademy platform. This is my profile. Overall 14 plus years of teaching experience, 11 plus of teaching experience for those who are preparing for GATE. Along with the channel, on this channel, I am teaching on Unacademy platform also so that people can learn. So what they can expect? GATE preparation content, strategies, motivations, and whatever the information they need for GATE and post-GATE. Everything we provide through this channel and Unacademy platform. If you haven't explored once, please explore the Unacademy platform also. Lots of classes are there which are absolutely free. How? Just go to unacademy.com or download Unacademy Learner app, and after that GATE and ESE category, in that category you just make your account and then you just search my name. Under my name you will get special class section. That special class section is free classes. Access all my previously taken special classes on this link also. If you guys are following me on Unacademy platform, well and good. If not, then follow me, and if you are the first time learner, use this code to unlock all the free classes on Unacademy platform. If you are preparing for GATE and if you find yourself into that situation that you will have to prepare in better and organized and structured manner, you'll have to solve all the type of question possible from a particular content so that you will always know that if this is the learning we have, this is the content we have, where we can use this content to solve different types of problem. And that is where you will need a very organized, structured, and very systematic learning program, which is here Unacademy Plus. This Unacademy Plus program will give you live classes, daily practice problems, weekly tests, structured courses, unlimited access of different batches, and moreover, you will be getting the guidance of the top educators of the country. If along with this, you want more personalized and customized preparation, go for Iconic subscription. This Iconic subscription has benefit of Unacademy Plus and additional benefit of personal coach. So what that benefit will help you in? You don't have to think anything. You don't have to understand that what should be the strategy next I should follow. Nothing you'll have to think. A coach will help you in building your one-on-one guidance strategy and one-on-one customized study plan. Your performance will be tracked. Booster session, personalized test analysis you'll be getting. Apart from that, you'll be getting dedicated doubt clearing educators, personalized, and you'll be having practice sets and notes separately. So if you want to join Unacademy Plus or Iconic, whichever subscription, you guys are having an offer. Offer is if you take 12-month subscription, 3-month extra, 4-month subscription extra for the 24-month subscription you'll be getting, and that offer is up to only 24th of March. Plus, this particular subscription price is going to hike by 10% very soon. So what you need to do is use the code VDEEP10 and you'll be able to get 10% instant discount plus my personal guidance, plus this particular offer, plus my team's support. Look at this, a new batch also starting with my course only, COA, which is starting from 23rd March. So take the subscription and learn this particular course from me on Unacademy platform. Look at this. These are some of the toppers of the GATE 22 who were classroom students. Yes, my dear friend. And you can take Unacademy Lite subscription also only for the test series if you want to, which is not of too much of prices, but in that also you can get 10% instant discount with this particular code. Okay, I'll provide you data structure revision here. That's great. Fine. But before that, I'll have to ask a simple question. Are you guys ready? You guys are ready? Okay. If you guys are ready, just type down in the comment box ki ready hai ya nahi. Aptitude course available for all branches. It's common. Yes, aptitude is available for all branches. Common. It is for common. Okay. Hold on a second. I am away from the screen. Does not matter. I am away from you. Just tell me that you guys are ready or not. Type down in the comment box. जल्दी से स्टार्ट करेंगे सेशन को. ओके, रेडी रेडी रेडी. तो सेशन को लाइक कर दीजिए और जल्दी से स्टार्ट करते हैं सेशन को. ओके okay, fine. Let's begin with the array. Array is nothing but collection of homogeneous elements. Homogeneous means similar data type, nothing but similar data type. So homogeneous means similar data type element collection. That is called as array. Fine. There are two characteristics of array. We should know all the elements should be stored on consecutive locations. One. Second thing, all elements can be accessed using a set of indexes. Look at this. If you are going to have an array in the C language, how do you define the array? You define the array like this way. Type space name and size. Right? From here, we know that lower bound is always 0. Upper bound is size minus 1. You all know that? Yes. But in data structure, how do you define the array? You define the array like this way. There is no any data type or something. So directly the name and lower bound colon upper bound, or in fact you can write name like this way also. Name lower bound dash 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 upper bound. इस तरीके से आप डेटा स्ट्रक्चर में एरे को डिफाइन कर सकते हैं. फ्रॉम हियर, इफ you will be having size, how do you calculate the size? In this particular case, upper bound minus lower bound plus 1. This will be a single session, 4 hours. Not 4 hours, of course, it will be very less. Jaldi khatam kar denge, 3 hours minimum, 2 to 3 hours around it will be. Okay, chalo. Location of the array, location of the element of the array. Jaldi se formula batao. Tell me the formula. Base address plus w into I minus lower bound. This is the formula. If lower bound is 0 in C language, this formula reduces to base plus w into I. That's it. Okay. Next one is traversing in the array. How do you traverse in the array? For loop लिख दो जल्दी से. I is equal to lower bound I less than equal to upper bound I plus plus. And inside it, what you have, traverse or visit the element. Let's say visit the element A of I. That is the simplest formula. What is the runtime complexity of this algorithm? Theta of n. Why? Just because this loop runs n time. From lower bound to upper bound, all the elements traversed one time. Okay. ये सेशन आप अपलोड करोगे क्या यूट्यूब में? अरे ये यूट्यूब में लाइव है बेटा, और उसके बाद ऑलरेडी यूट्यूब पे रहेगा जब तक आपको देखने का है. ओके, चलो मिनिमम फाइंड करना है. हाउ टू फाइंड मिनिमम? टू फाइंड द मिनिमम वी हैव सीन अ वेरी सिंपलेस्ट मेथड. व्हाट इट वाज, टेक द फर्स्ट एलिमेंट एज द मिनिमम. आफ्टर दैट कंपेयर इट विद नेक्स्ट वन. इफ नेक्स्ट वन इज लेसर देन मिनिमम, make it minimum. Next, compare with the current minimum. Current minimum. You compare till the last and you keep updating. You have seen the method. Yes, let me just write down quickly the algorithm. Are you guys able to follow me? Follow कर पा रहे हो ना? Okay, so we are going to have minimum is equal to A of lower bound, and after that write a loop. K is equal to lower bound plus 1 to k less than equal to upper bound k plus plus. You can take I variable also. There is no any issue. है ना? सेंटिमेंट हर्ट मत करना, सर आपने k कैसे ले लिया, I ही लेना पड़ेगा यहाँ पे तो. अरे ऐसा नहीं है. You can take any variable whichever you want. It's a loop variable. That's it. So what you will have, a comparison. If the current minimum is greater, or I should say the current element on kth index is lesser than the current minimum, then update it. Minimum should be updated by A of k. Keep doing it till the last and you will be able to get the minimum. So return minimum. Okay, now what is the number of comparison needed for this particular method to get the minimum? Number of comparisons are equal to n minus 1 and run time complexity is theta of n. What is the space complexity? Space complexity is equal to constant. Why? Just because only two variables extra you have taken. One is minimum or one is k. Good, 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 good. Nice. Next, finding maximum. Same to same thing hai, yahi ka yahi. I am not going to write the algorithm again. Why? Just because the comparison will be just opposite and we will try to find the maximum. Same thing. Number of comparison will be exactly same. If only maximum we are finding, that is equal to n minus 1. Run time complexity will be theta of n plus space complexity is equal to theta of 1. All the people who are the toppers, yes, GATE 22 toppers, there is a link available in my all the current videos. In that particular link, the link is about toppers reward program. Just go to that particular link and fill the form, just because you are going to get the reward from Unacademy. Okay, next one, finding minimum with the tournament method. What tournament method says? that make 2 2 2 2 comparison, minimum element goes to the next level like that way, and it continues 7 4 and ultimately 4 wins, that is minimum. This is the tournament method. हमने देखा है ये भी. Yes, we have seen that. In this method also, the number of comparisons will be equal to same. How many? N minus 1. Or what will be the runtime complexity? Same to same, theta of n. But here, the space complexity will increase, which will become n. Why, sir? To store this list. That is why. Number of comparisons will be same to same, but only space complexity will increase to store these list of winners from the first level. Then we have seen finding minimum and maximum. What I told, if you have n number of elements, 2 element comparison we will make. We will copy smaller elements in a list or in an array of only smaller elements and larger elements here separately. N by 2 elements here, n by 2 elements here. Find minimum of this, find maximum of this, and you can get minimum and maximum both with number of comparisons. How many? Number of comparisons this time will be equal to 3 times n by 2 minus 2. If n is odd, like your destiny, your fate, your luck, आपका लक भी तो अभी तक ऑड ही चल रहा है. लेट्स ट्राई टू मेक इट इवन इन योर फेवर. बाय व्हाट? मेहनत करना पड़ेगी बॉस. 3n by 2 का सील वैल्यू -2 if n is odd. Great. Runtime complexity is same to same. Space complexity, of course, extra needed just to store these lists. Second minimum. You can skip this. इतना जरूरत है नहीं. Next thing we will see is searching in the array. There are two types of searching we can have in the array: linear search, binary search. Linear search can be applied on any array, but binary search can be applied on a very decent array, very cool like me. Sorted array. Yes, on only sorted array. Why? Just because binary search has the method of applying the searching in that way that we will go with one direction only or in one side only after checking the middle element, right? Okay, great. Next is linear search. Let's try to understand linear search. We will search the element on the first position. If we get it, we will return its index. If not, then here we will check. If comparison result is true, if not, then this linearly we will check till the last. If till the last also we don't get the element, then we will say, okay, element nahi mila, sir. Like you are searching. So you'll also have to search your rank of gate or some admission linearly only, one by one by one, 1 hour by 1 hour, 1 day by 1 day, 1 by 1 week. You are just preparing linearly. But the person who will search with more intensity will get it. Otherwise, you will say unsuccessful search. I don't want that. You also don't want that. Chalo. So what is linear search? Linear search comparison will start from the first to the last. Let's write a loop for this. K is equal to lower bound, K less than equal to upper bound, K plus plus. Fine. Now what I'll have to do? I'll have to have a comparison. If on the array on index number K, it is same as the element which we are searching, then return K. That's it. Index of that element return. If this loop completes and no any item is matching, I mean no any element is matching with the given item, no return happens. Hence, I'll have to return what? Lower bound minus 1. What is the runtime complexity of this algorithm? Big O of n. Why? Just because you may go from first to last. It might possible that you may go only for 2 comparisons, and that's it. By plus subscription, we will be too sorted. Yes, you were already sorted and the things were sorted. Now let's sort the future. Okay, binary search. Binary search says that we will directly jump to the binary search में ये क्या लेके आ गया मैं? कैसे चलेंगे रे बाबा? Sort करना पड़ेगा इसको. गलती से आ गया. So in binary search, what exactly you do? For binary search, you jump to the middle element. If the middle element you are finding, how do you find middle element? You find middle element by low plus high divided by 2. Right? This is the formula to get the middle. Now on the middle index, you will check out which element is present over here. Is it the same which you want? If yes, then return its index. If not, then either you will go towards left or right. Just because the array is sorted, we know that smaller elements will be here, larger element will be here. So what you will do, you will check the element which you are searching is smaller than this, then go towards the left side. So what you will write as a comparison result? Only 2 statements I am writing. If the element item you are searching, that particular item is lesser than the middle index element, then you will have to update what? You will have to update the high by this one. So you'll have to update high index by which one? Which one? Mid minus 1. Otherwise, you'll have to update low, just because you are going to go into the right direction. If item is greater than A of mid, you'll go to the right direction, means you will search only into this half. How do you do that? Low you will update by mid plus 1 and keep doing this until you get the element, or you have low lesser than equal to high. When the low and high will cross each other, means we can understand that we have minus 1 or less than 0 number of elements, or less than 1 number of elements in the list where you are searching. See, when the let's say you are going half, you have reached to certain particular element which is low itself and which is high itself. Okay, fine, we understand that one element is still there in the list where I'll have to search. Total list, we have made it half, either left or right, then made it half, half. We are just going half, and half until we get one element in the list. After that, even though if element is not present and you are updating mid and you are updating low and high, what you will try to get? You will have low and high crossed each other. What does it mean? You are going to search in such kind of list which is having less than 1 element, 0 or minus 1 element. In that case, you can easily understand in 0 element, how can I search? Means element is not present, unsuccessful search. If unsuccessful search, you will return lower bound minus 1. That element is not present. नहीं मिला हमको. 2D array. I think 2D arrays are not at all getting asked nowadays in the exams, but only 2 things you will have to remember, and that is their row measure and column measure order ka formula. Okay, so what is the row measure? Row measure is, if 2D array you are having, you are storing the array in the row wise manner. First these elements, then these elements, then these elements in the memory, main memory. Column measure order says that you will have to store the elements in this particular manner. For first column, then next column elements, next column element, and so on. Will we get PDF of this lecture? Do you really need PDF of this lecture? You can get it. So if you have 2D array, let's say you have m cross n ka array. What does it mean by that? You have m number of rows and n number of columns. Okay, if you have that particular thing, fine. Sir, if you allocate an array in the C language, you can write like this way: 3 rows, 4 columns, no problem. But if you allocate the same array in the data structure for rows and columns, for both, you may have different starting index. Lower bound can be different. Yes, in C language, so we know that row number starts from 0, column number starts from 0. But what? In the data structure, it may change. So it may change to what? It will be like this way: array, lower bound of rows, I am giving a subscript I for this, colon upper bound for I. Similarly, lower bound for j, colon upper bound for j. These are the way, this is the way you can get the array. Now from here, if I want to know how many number of rows we have, number of rows will be upper bound minus lower bound plus 1 for the rows, means I and I. Similarly, n, upper bound minus lower bound plus 1 for the columns, j and j. Good. If row measure order, somebody is asking you to get the address location of A of I comma j index, how do you get that? Formula याद है, base plus w into I minus lower bound of I into number of columns plus j minus lower bound of j. Similarly, for the column measure order, formula of location of A of ij is equal to base plus w into what? This time j minus lower bound of j first into number of rows plus I minus lower bound of I. Woohoo! Good. Next is linked list. We have two major discussion point in array. First one is it can store all the elements on the consecutive location. Hence, using the index, you can access any of the element randomly directly. You can jump to any element, yes. But problem is, because of its static nature, we will have to provide the size of the array at static time. Hence, the increment, or I should say, hence the flexibility is less in the scalability, that if we will have to store more elements, we may face the problem or issue, right? And that particular problem can be solved here through linked list. Similarly, another problem was there in the array, that to insert a specific element in the middle, it was causing a lot of trouble, that we had to shift lots of elements. Here, it will not be the problem. So linked list is what? Same, a linear data structure only, but instead of using the consecutive memory locations to store the elements or providing the linear order, using the pointers, we will provide the linear order here. तुम लोग फॉलो कर पा रहे हो मुझे? आर यू गाइज एबल टू फॉलो मी हियर? Good. So linear data structure, linear order maintained using pointer, the links. List contains lots of nodes. Each node contains two things, data and link. The last node, if let's say this is the node, it is having data and link to the next, data and link to the next, data and link to the next. Last node is not having any link, so it contains null pointer. There is a list pointer. Name of the list pointer can be different, head pointer, list pointer, start pointer, whatever you want. That particular list pointer points to the very first node. From there, you can reach to the second to third, and so on. 3D array is not there in our syllabus for data structure, so don't worry about it. Fine. Now, if you want to have the linked list ka structure, how to get a node ka structure? Struct node. In the node, you have two things. What type of data you are having, character, integer, float, whatever you can have. Let's say character type of data you are having, and another is a pointer. Of what type? Same node type. So struct node star ptr. Now pointer name you can have as next, you can have as forward, you can have as right pointer, you can have as link, whatever you want to give, you can give the name to this pointer. This data also sometimes key, sometimes value, etc., etc. Gamers name, you can search anywhere you want. Empty list condition. If there is a list which is empty, then what should be the condition? If list is equal to null, or another point you can write the same way is not of list is true. Similarly, if you have single node in the list, how can you know that single node is there in the list? If list ka link is equal to null. List pointing to the first node, its link is null, then single node, or same kind of condition you can write like this way also, if not of list ka link. That's how you can write these condition. If null pointer dereferencing, then what is that? If at any moment you have null pointer, arrow, some kind of member you are accessing. Whenever such situation occurs, you are accessing some member, maybe data, link, whatever, using a null pointer, then there will be an error, runtime error called as null pointer dereferencing over there. Such kind of question, quickly you can solve it now at least. अब तो सॉल्व कर ही सकते हो, ट्राई करके बताओ जल्दी से. What is the answer of this question? Gamers, you create your account on Unacademy platform and join my few of the special free classes over there. Come to the live and you will be able to access me over there. You can discuss the things. Struct P, pointer P you are creating with start link, start link. Pointer P updated with this one. Then start link, start link and its link, this one, this pointer updated by what? P link, means next node of P, this one. After that, P link, P link and link is equal to P. Now print start 3 link and data, start link and link, and its data 1. It is gonna print 1. 3 कहां से आ गया? 3 तक तो एक्सेस ही नहीं रहेगा. There is no any access till 3 at all. There will not be any access to the link at all. 1 is the output. Traversing in the linked list. Traversing means start from first, go to the last node and print or traverse or visit, process whatever you want to do with that particular node. So what you will do, you will have a pointer of struct node type P. That pointer you will initialize with the first node. Let's say the name of the list pointer is a start I am taking. After that, you will have to have a loop while p not equals to null till p reaches to null. Till then, you just continue and access the data part by p, pointed by p. So I'm saying process the data part pointed by p, or access the node, process the node pointed by p. Whatever you want to do with the data, count, node, whatever you want to do, go for it. And at the end, increase the pointer by next node's address. So p equals to p ka link. That's it. Keep doing it. The runtime complexity, theta of n. Loop runs n times always. Finding address of the last node. What should I change in this particular traversing ka function or algorithm so that I can get the address of the last node? For that, the loop should run till p link is equal to null or not equals to null. Till that time, I'll continue p equals to p connects, p equals to p connects. But it might possible that start is null, hence p becomes null. If p becomes null, p arrow link not equals to null condition will give me the p pointer starting from start. Fine. And I write the condition while p ka link not equals to null. Till then you continue, and what you'll have to do here, p equals to p ka link, and at the end when p reaches to the last node, this condition falls and return p. Fine. But what is the problem here? If p becomes null at initial level, null arrow link will give me npd, null pointer dereferencing. So I'll have to check a condition here. If p is equal to null means empty list. In empty list you don't have last node na. So if empty list is there, then return null. Directly yahi se return kar do null. You don't go further with the further execution. Otherwise go with the further execution. One more thing, एक और चीज जो मैंने यहाँ नहीं लिखी, इसको आप कैसे लिख सकते हो? While p also you can write till p is true, continue that. Similarly, this particular statement you can write like this way also. While p link is true, continue this. When it becomes false, null, stop. Runtime complexity same to same as theta of n. Why? Just because of traversing. Similarly, counting the nodes in the list. I am skipping this just because you know what to do. There is a counter. Count is equal to 0 initially, and write exactly same algorithm. Instead of process, you just do write count plus plus. That's it. Other than that, nothing. Same complexity, theta of n. No changes. Searching in the linked list. You can apply only linear search here. Why? Why, sir? Why? ऐसा कैसे सर? क्यों सर? Just because you don't have the liberty to reach to the middle index directly in the linked list. Middle पे नहीं पहुंच पाएंगा. Directly नहीं पहुंच पाएंगा. Not possible. So only linear search is applied. Okay, fine. I'll accept this. What is the algorithm? So first of all, you'll have to run a loop. For that you need a pointer p of type node starting from the first node start pointer. You will write the loop like this way. While p is true, keep doing. What? I'll have to check if p pointing to a node where there is a data which is matching with the item, then you will return pointer p. Just because p pointer points to that data which is matching with the item. But if this condition is not true, you are not returning anything. Let's move to the next node. If let's say you are moving to the next node, this particular loop runs completely. This condition never satisfied. No return till now. So you'll have to return at the end null after the loop completes for the unsuccessful result. The runtime complexity is big of n. Good. Nice. Insertion in the linked list. For insertion in the linked list, you will have to create a node. And you will have to insert it at given place. What is the given place? You can insert the node anywhere you want or based on the requirement of the application. So how to create a node? You know a malloc function, malloc function is used to do that. Okay, no problem. Fine, let's have insertion at beginning. If we are inserting at beginning, सर मेरा एक सेमेस्टर में 8.66 सीजीपीए आई है, अच्छी बात है, बहुत अच्छी बात है. 8.66 is good. So if you are inserting data item, you will insert here. Its pointer you will update by start, means new node is pointed by n, its data is equal to given item. After that, n ka link you are updating by current start, and start pointer you are updating by new node ka address, so that new node inserted at the starting. What is the runtime complexity of this algorithm? Constant one. Next one, insertion at the end. If you are inserting a new node at the end, do we know the address of the last node? No. So first of all, we will have to traverse the list and we will have to reach to the last node. Once we will reach to the last node, after that insertion happens, new node ka data item updated, its link is equal to null, and current last nodes ka next should be this one, so that we can update this pointer not by null but by n. For that we need to know the address of the last node, and for that we will need a traversal. That is why the runtime complexity will be theta of n. It will be on 23rd morning. Gamer, next class. Insertion at the end when the address of the last node given. Let's say last node's address is maintained always. So in that case, insertion will be very, very easy. Why? Just because look at this. What happens? Last node's address is given, n, new ka data updated, last pointer null, last node next is this, and update the last node by this address. Only 4 statements you will have to write. And when the last node's address is given, after that if you are inserting, it will take constant time. ठीक है, चलो आगे बढ़ते हैं. Insertion after a given node. Let's say some intermediate node's address LOC given. You will have to insert a new node here. So what you need to do, new node data item updated, its next is equal to LOC's next, and LOC's next updated by n. These are the 3 statements you will have to write. That's it. Runtime complexity constant. See, these things mostly will not require any kind of code in the examination. For GATE exam, most of the time you will be having the conceptual utilization that, okay, this is the application, this is required. Now tell us that what is the runtime complexity of this requirement. That requirement may have the requirement like this way, that insertion after a given node, insertion at the end, insertion at the beginning, insertion at the end when last node's address given, etc, etc, etc. So you'll have to just find out what is the runtime complexity. Okay, chalo aage badhte hain. Let's go further. Insertion before a given node. Let's say a node is given LOC. Before that, I'll have to insert a new node. When I'll have to insert a new node here, data item updated, fine, link updated, fine. But one more thing I'll have to update. Previous of LOC, whatever the predecessor node of LOC we have, its next should be n. But do we know the address of predecessor? No. I'll have to find out from start. So start from the first node and pointer p will go to the next until pointer p reaches to here, whose next is current LOC. And for that I will need a traversal, but till the last always? No. Up to that level where I can say that pointer p is pointing to the predecessor of LOC. In that case, runtime complexity will be big O of n. It depends where the LOC is given. First, last, intermediate, where. Good, Tanmay, nice. So until p link not equals to LOC, we will continue, p equals to p ka link. Chalo. Next, deletion of the first node. It is so simple. Start updated by start ka link, and that's it. And it will take constant time. First node deleted. Second, deletion of a given node. Let's say this is given as LOC. I'll have to delete that. To delete that, predecessor of LOC, link pointer should point to LOC is next. Do we know the predecessor? No, I'll have to find it. Yes, by traversal pointing pointer P from here to the predecessor of LOC. For that, we will require complexity big O of n. Why big O of n? LOC, if it is in last, then pointer P will traverse a lot. If LOC is very close to the first, and then LOC will, or pointer P will not traverse a lot. That's why big O of n. It may be maximum n lesser than n. Next is deletion of the last node. For that, again, I'll have to traverse to the second last node. When I reach to the second last node ka link becomes null. Last node automatically removed from my list. And for that, I need complete traversal till the second last node. Theta of n is the complexity. Deletion of a node when the last node given, when the last node address also given, does not matter. I'll have to reach to the second last node. When I'll have to reach to second last node, from last node we cannot get the second last node's address. Hence, anyway I will require a traversal which will require theta of n. So deletion of the last node, in fact, whenever the last node's address and whenever last node address not given, in both the cases it will take complete traversal theta of n. If second last node's address is given, then we can make it in the constant time. But to maintain the second last node address, again I'll have to traverse. Let's say second last node address is maintained. Fine. I have deleted this node once, making this as null. Okay, fine. Now after that, I'll have to update the current second last node address into the pointer something. Yes. How can I get the address of this node? For maintaining second last node address, we cannot. Hence, it will take complete traversal. Yes. Means again theta of n will be needed. Anyway, theta of n needed. Disadvantage of singly linked list. Two major disadvantage. First is we cannot have a traverse back, means predecessor's address is not known. Second thing is the last node is pointing to null, means that particular information is not being utilized. So to solve those problems, we are having some specific kind of list. One is header list. Header list says that the list start from the second node. First node is not containing any kind of data or specific items. It is not containing the data or items. It is containing specific elements or specific information about the same linked list, which we want to access again and again, so that we can access it in the constant time. We don't have to calculate it every time. So let's say number of nodes or summation of the integers, we can maintain here in the data part of the header node. If somebody asks how many nodes are there, 1, 2, 3, 4, 5 nodes are there in this header list. Header list is of two types, grounded and circular. Grounded means here last node should point to null. Circular means last node should point to the first header node. If that is the case, for traversing in the grounded and circular header list, the traversing algorithm will be like this way. First of all, first node address. First node address is actually not this one, it is this one. So list pointer pointing to the header node, its link is my first node. Starting my traversing from here. After that, in the grounded one, what do we write as the condition? While P is true, but here or not equals to null, right? While P not equals to null, we write it like that way here. But here, while P not equals to list again. Why? Just because it's a circular one and the remaining algorithm is same to same. Will you resume? No. Right now, no any plans. Doubly linked list. Doubly linked list says that we'll be having the node having two pointers. One is forward pointer, one is backward pointer. Why do pointer क्यों? Just because we wanted to have the access of predecessor also, so that we can traverse in the backward and we can save a lot of complexity by saving the predecessor's node's address too. So each node will have two pointers. One is next nodes and one is previous node's pointer. Okay, now what we need to do for this structure, struct doubly node structure will have now three members. One is character type of data, like you, a special character you are, है ना? सारे स्पेशल कैरेक्टर नमूने हो सब, समझते हो नमूना क्या होता है? इन माई चाइल्डहुड नमूना उस पर्सन को बोला जाता था जो स्पेशल कैरेक्टर होता था, जो सबसे ज्यादा अलग रहता था, मस्ती करता था बहुत ज्यादा, उसको बोलते थे नमूना. फुल रिवीजन अभी क्यों हो रहा है? पीजीडब्ल्यू देना है, एचएएल देना है, बार्क देना है कि नहीं देना है? आईआईटीज के इंटरव्यू देना है, नहीं देना है? उसके लिए क्या लगेगा? चलो कोई बात नहीं. Denote type of pointer, we can have forward pointer, we can have backward pointer, or we can have next pointer and previous pointer. Name of these pointers you can have based on your own requirement. अपनी अपनी मर्जी से तुम इन pointers को नाम दे सकते हो, but two pointers you'll be having. Sure. Insertion at beginning. In doubly linked list, if we have insertion in beginning, it is again a very constant time option. Just because, look at this, in the doubly linked list, remember, last node next pointer is null. We know that the previous node or previous pointer of first node also is null, just because there is no any previous of the first node. So what we need here to insert data item here, previous null, next this, previous of the current first is this, and current first to this. Constant time affair. Quick, we will have to go through this very quick. Insertion after a given node. If LOC is given, insertion we need to do, we can access its previous, next, both. So it will be again a very constant time operation. Insertion before a node, this will be again a constant time operation. Why? Just because everything will be updated in the constant time. Look at this. You don't require any traversal, just because we can reach to the predecessor node from LOC itself. That is why again it will be a constant time operation. Insertion at the end. When the last node's address is given, insertion at the end here will take constant time as the previous singly linked list insertion type, same to same thing. But if we have last node not given, last node's address is not given, and insertion at the end, for that we need to know the last node's address. Why? Just because insertion will require the address of the last node here. I'll have to have some updations, and because of that it will take, yes, theta of n runtime complexity. Good. Next, deletion from starting. If first node, I'll have to delete, again a constant time operation, first equals to first ka next, and first previous is equal to null, constant time operation. But if we will have to delete the given node, let's say LOC is given, this node deleted, given node deletion will be very easy, just because predecessor is known, next is known, only 2 points that I'll have to update this one and this one, that's it. And we can reach to this node with the LOC itself. Yes, constant time operation. Deletion after a given node. If LOC is given and this node to be deleted, that is again a constant time operation, just because we can access from LOC this node, both, and these nodes pointers will be updated. Similarly, deletion before a node, this one if you delete, LOC, previous ka previous, everything we can access from the given node, again constant time operation. So most of the operations will be constant time in the doubly linked list, just because we can access the predecessor easily. चलो आगे बढ़ते हैं. Deletion at the end when the last given. If the last node is given, here deletion will be constant time. You know why? Just because second last node's address you can easily get. From here, second last node address you can get easily, make it null. That's it. Last is equal to this one. That's why. Yes, Nishu. But when the last is not given and I'll have to delete this one, you will have to traverse till the last. And for that, you will need theta of n complexity. Sure. आगे बढ़ते नेक्स्ट देखते हैं क्यू. क्यों linear data structure? Yes. Insertion done from rear end, deletion done from the front end, called as FIFO list also, just because first in first out method it follows. Then we have the implementation of the NQ using array. We don't have to see the algorithm at all. We need to just check out the just one thing, overflow condition. What is the overflow condition? If we have, you remember, next index of the rear is equal to front. So we will say front is equal to rear ka next means rear plus 1. But in the wraparound means mod. In that case, it's an overflow. That's it. Using array, if you are implementing DQ, in that you need to understand the underflow condition. What is the underflow condition? When rear and front both are equal to -1. You can say there is no any item, there is an underflow. Good, Nishu. Nice. Implementation using linked list. The best implementation possible is I am explaining, but multiple implementations can be possible. Why best? Just because in that implementation, constant time insertion deletion is required. These two algorithms which we have seen in the classroom, both are having constant time operation only. I don't think so you will require the algorithms anywhere, just the condition you need to understand. Here also, when you are implementing the link queue using linked list, it is so easy. Front and rear, 2 pointers you are maintaining so that you can have the easy or convenient or fastest possible operation. So if you want to perform NQ, you will have the insertion from rear end of means insertion at the end. When the last node address is given, it takes constant time. And if you will have to perform DQ, DQ will be deletion from the beginning, and that will take constant time just because first node's address is known. This is the standard one, but it can be flipped also, which was asked in 2018 GATE paper, that we are having insertion from the front and deletion from the rear. Complexity may change, you know how to do that. Chalo. Double-ended queue. Double-ended queue is that queue which has insertion and deletion done from both the ends. It is having two flavors, input restricted and output restricted. Input restricted says that input is restricted to the standard and rear end, means in the input restricted, NQ can be done only from the rear end, but DQ can be done from both the ends. Output restricted says that output is restricted to the standard front end, means output DQ operation can be done only from the front end, and insertion can be done from the both the ends. Priority queue. Priority queue says that each element has a priority in the queue, while DQ, which element to delete first? Delete highest priority element first. That is the priority queue. Good, good, good. Then we have stack. What is the stack? Stack is a linear data structure in which we insert and delete from both from the same end, called as top of the stack. That is why this particular stack is called as last in first out. Whichever comes first should be going at the last. Whichever comes last should be going first. Push. For push, we had an algorithm using array. Should I write it? It was a constant time operation. I'll take an algorithm very simply. First of all, overflow. If the top index reaches to the max index, max of the top or the max of the stack, then overflow, return. If not, then we will just make top plus plus, and on that index you can insert the element in the array stack. If we will have to pop, then first of all we will have to check the underflow. If top has reached to -1, then underflow, and then return. If not underflow, then just do top minus minus. That's it. Constant time operation. Again, implementation using linked list. The best implementation is what? Push, pop, both you do from same end, from starting or beginning. And in that case, both will require constant time. But implementation can be different. You can have from the last also, and something other information also can be given. Depends how exactly you are having the implementation. Best implementation is pointing the top is pointing to the very first node, insertion and deletion both from the beginning only, same end. Stack permutation. Stack permutation means you push an element, delete it. Whenever you delete the element, print it. In what sequence you are popping out the element from the stack. That is the stack ka permutation. For that, sequence of the element will be always given. And if you want to know valid stack permutations, how many valid stack permutations with a sequence of n unique input, it is equal to Catalan number 2ncn divided by n plus 1. And the total invalid stack permutations will be equal to n factorial minus this valid ones. Good. Nice. Multiple stacks in a single array. If we want to have multiple stacks in single array, two options are there. Divide the array in two parts, or you start the array or the stacks from two different ends. This is old school just because it does not utilize the space of the array too much. That's why this is the best one. Two stacks starting from two different ends. One is the top one, top two top indexes. One is in 0, one is on n. Not 0 exactly, -1, just because 0 is the very first index of the array from 0 to n minus 1. So when you want to have the overflow condition for any of the stack, the condition is very simple. Top 2 is equal to top 1 minus, or top 1 plus 1. Top 1 reaches to an index which is just 1 before top 2. Top 2 is equal to top 1 plus 1. That is the condition of overflow. You can write it like this way also. Top 1 is equal to top 2 minus 1. Underflow condition. Two different condition you'll have to write. For stack number 1, the condition should be when top 1 reaches to -1, and for stack number 2, condition will be different when top 2 reaches to n. Underflow is there. Anshika Yadav, yes, search my name, you will get it. What is the answer of this question? What is the minimum number of stacks of size n required to implement a queue of size n? Answer is 2. 2 stacks are required. And what is the method? Method is very simple. You will have insertion in the stack number 1. Always insertion here only. For deletion, you will check if S2 is not empty. If S2 is not empty, pop an element from S2 and deletion is done. If not, S2 is empty, then bring all the elements from S1 to S2, and whatever the top element is there from S2, delete it. That is the method we have seen in the very rigorous manner. Okay, चलो आगे बढ़ते हैं. एप्लीकेशन ऑफ स्टैक, इवेल्युएशन ऑफ एक्सप्रेशन एंड रिकर्शन. Three types of expression notations we have: prefix, infix, postfix. Prefix says when operator is placed before all the operands. Infix, operator is placed between the operands. And postfix, when operator is placed after the operands. But to solve these prefix to infix, infix to prefix, etc., 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 we need to know two things: precedence and associativity of the operators. These are the precedence or preferences from high to low, and here we will have to have the associativity. So you need to solve the operators in this sequence: first bracket, then exponent, then multiplication and division, then addition, subtraction, then assignment. You cannot solve plus minus before multiplication if we don't have plus in the bracket. If there is a bracket, we'll have to do that. But if two operators are there of same precedence, then we will have to allocate, or we will have to understand that associativity is what. Based on associativity, you will solve the next operator. So associative will come into the picture only when two operators of same precedence are there and we are having confusion then which one to solve first. Okay. So associativity of parenthesis is left to right, left associative. Exponent is right associative. Multiplication, division, left associative. Addition, subtraction, left associative. Assignment, right associative. If you have seen modulus operator, percentage operator of C language, that is division only, so you will have percentage also in the same category. Infix to prefix and postfix. If you are going to convert infix to prefix or postfix, you will have to first check out which operator is having highest precedence. If multiple operators are having highest precedence, then go for the associativity. Right now, highest precedence is this. 3 exponent to write in the prefix like this way. Postfix 3 to exponent. Fine. After that, remaining expression, multiplication and division, both are of same precedence. Go with the left one first. Left one is multiplication, so do multiplication of 6 with this. Multiplication, left operand this, right operand this. Postfix 6, left operand, right operand, and multiplication. After that, you can do division. So how will do? Okay, division, left operand and right operand. This, then 8, then right operand. Right operand 8 and operator. After that, 2 minus or plus 9 first. Minus. Why? Just because of the associativity. Plus and minus both will have same precedence. Look at this. So associativity is left one first. 2 minus first. Minus 2. After that plus 9. Here also 2 minus and after that 9 plus. These are the conversions. Prefix, postfix. Quickly. Prefix same to same. Postfix this. Log. Prefix same to same. Just because log is an operator. Postfix is x log. X factorial already in postfix. Prefix is factorial x. Here factorial is having higher precedence. So first of all prefix and prefix of that. Postfix and postfix of that. Infix to prefix and postfix. Quickly solve it. Okay, Nishu, that's good. Solve it quickly. जल्दी से सॉल्व करो जरा इसको. तुम लोग को सॉल्व करना है, मैं थोड़ा सा रिलैक्स करता है. कर रहे हो सॉल्व? चल उदयन गुप्ता, क्या बात है. Prefix first of all plus AB and its multiplication with minus CD, division by F, then minus of division multiplication x, y, z. And postfix will be like this: a, b plus c, d minus multiplication f division, then x, y multiplication z division and minus. This is the answer. Check it out. Are you also having the same answer? Sure. Postfix evaluation. How to do the postfix evaluation? Everybody knows the method. First of all, check out from left to right. Whichever the symbol comes first, if it is operand, push it onto the stack. If it is operator, take two operands. This is top, this is next to top. So next to top, second top, and top element, you will perform the operation. So look at this. This is the algorithm. Scan from left to right. Pop two elements when operator is encountered. A is top element, B is next to top element. Evaluate B operator A. Just because top element is the right operand and next to top element is the left operand. So left operand and top element is the right operand. Perform that operation. Push the result onto the stack. When entire scanning left to right done, at the end, top of the stack gets the result. Chalo. Question. Very easy. Ten plus 5, 15. 30 divided by 6, 5. 5 into 5, 25. Into 3, 75. Into 5. 75 into 5 is कितना हो जाएगा यार ये? 150 गुना दूना 375 plus 15 plus 370, 390 minus 8. 390 minus 8, 382. ले निशु, ये वाला वो क्वेश्चन नहीं है बाबा, चेंज हो क्या आया? गेट का क्वेश्चन का आंसर हर जगह थोड़े काम चलेगा. 382 is the answer. Good. जे वो क्वेश्चन नहीं है. Then if we have prefix evaluation, only two things will change. One thing is scanning from right to left, and instead of B operator A, you'll have to perform A operator B. Just because when you will go from right to left, first goes to the down, next comes next. So top element will be the right operator, left operand, and next top element is the right operand. So you'll have to perform the operation in the sequence only A operator B, and the rest of the things are same to same. That's it. Question. Evaluate the following expression using stack and return the result. क्या आएगा? ये डायरेक्टली आप यहां से राइट से लेफ्ट की तरफ सॉल्व कर सकते हो. 5 plus 8, 5 plus 3 8, then plus 4 12, 12 into 9 कितना हो जाएगा? 108. 3 divided by 108, so answer will be 3 divided by 108. अरे 3 डिवाइड बाय 108 आएगा. 1 डिवाइड बाय 36. यही तो गलती करते हो तुम. यही मिस्टेक करोगे. चलो. Recursion says when the function calls itself, it is a recursion. Means function is calling itself directly, maybe directly, indirectly, whatever. A good recursive function should have two characteristics. First one, it should have a base condition for which the function does not call itself. Otherwise, function will call itself continuously indefinite time until the stack overflows. Otherwise, second thing, every time a function calls itself, the base condition should be coming closer. Means the function should come close to the base condition every time it is calling to itself. Cool. Types of recursions, we have direct, indirect, nested. We don't have to see that. You just solve the problems. How do we solve the problem of recursion? By making the recursion tree. If you have seen questions along with me, you know how to draw the recursion called tree. When you draw the tree, always you'll have a correct answer. Just reach to the bottommost level, just because there only in the base condition you will have the actual essence of the recursion. Fine. So you will call the function with 4 integer x becomes 4, 4 greater than 0. Yes. So it will have in the function of 4, you will be having two things executed. First of all, function of 3 called, then print of 4. Function of 3, 3 greater than 0. So it will have again two things, function of 2 called and print of 3. But print of 3 comes next. I'll have to call function of 2 first. It says that 2 greater than 0. Yes, so function of 1 call and print 2. Function of 1 greater than 0. Yes, it will have function of 0 call and print of 1. Function of 0, 0 greater than 0. No. So nothing is there. It is executed. Come back, execute the next statement 1. So print 1, done. Come back, this is done, print 2. Okay. After that, come back, print 3. Okay. Done. Come back, print 4. Okay, this is done. Come back, 1 2 3 4 is printed. Good. Then we have such kind of questions where the values are returned by the function. What happens in that? X of pi you call. Pi less than 3, no. So in else you'll have to return x of 5 minus 1 4 plus x of n minus 3. 5 minus 3 2 plus 1. Let's call x of 4. 4 less than 3, no. So it returns x of 3 plus x of 1 plus 1. X of 3 you call first. 3 less than 3, no. Else x of 2 0. X of 2 will give you 2 less than 3, yes, 1. Call for x of 0, 0 less than 3, yes, run. 1 plus 1 plus 1, 3. X of 3 is 3. X of 1, 1 less than 3, yes, return 1. 3 plus 1 plus 1, 5. X of 4 is 5. X of 2 returns 1. 5 plus 1 plus 1, 7. Answer is 7. Kya baat hai? Special question, yes. Then we have seen Fibonacci series. Fibonacci series starts from 0, n equals to 0. Fibonacci of n is 0, n is equal to 1. It is 1. For greater than 1, it is addition of previous two fib values. 0 plus 1, 1. For 3, 1 plus 1, 2. For 4, previous two values, addition 3. For 5, it is 5. 6, it is 8. 7, it is 13. 8, it is 21. For 9, it is 34. 10 is 55 and so on. That is the Fibonacci series. Then we have seen the tower of Hanoi function. Tower of Hanoi function says that we have n number of disks on the start tower. We will have to move those onto the end tower and using the offset or intermediate tower. But how? There are two rules. First rule, at a time only one disk can be moved, and second rule, when you move the disk, you can keep lower disk always higher or bigger and upper disk always smaller. So lower disk larger, upper disk smaller, you can have it easily. Right? For that, what is the algorithm needed? When you are moving using the tower of Hanoi function, n number of disks from beginning tower to end tower as the intermediate tower as auxiliary tower. First of all, if n is greater than 0, then only you can move the disk. What you will do? You will call tower of Hanoi function. First of all, n minus 1 disk you will move from beginning tower to auxiliary tower so that the largest disk only will be here. All the n-1 disks are on this one. N tower is free. For that, you'll have to use n tower as the intermediate one. After that, move a disk, the largest one, from beginning tower to the n tower, and then recursively n-1 disk moved from auxiliary tower to n tower using the beginning tower as the intermediate one. The runtime complexity of this will be 2 power n, because when n number of disks are there, number of disk moves are 2 power n-1, and number of function invocations are 2 power n plus 1 minus 1. These many times you will call the function recursive. चलो, तो अभी एक छोटा सा ब्रेक लेंगे, 10 minutes. We'll meet again at 3:31 it is. We'll take a small break of 10 minutes. 3:41 again we will meet and we will continue the remaining session. Why I'm taking break? मुझे थोड़ा सा गले को आराम देना है. You also take a break and इसके बाद we will start tree and we'll go for the other topics. Okay? Till then, you listen this everyone, welcome back. चलो स्टार्ट करें. शुड वी स्टार्ट? सर डीएसए की लाइट में पर सब्जेक्ट 3500 रिकॉर्डेड वीडियो नहीं मिल सकती क्या? आर वाई ज्ञान? नहीं, बिल्कुल नहीं. You can only take one thing, which is Unacademy Plus subscription, to get access of all the lectures, not on single, all the lectures of all the educators since the first day of Unacademy till today and future. Okay. So many people are not present over here. Come back, buddies. Come back. Come back. Come back. You guys are back or not? Chalo, start करें. The second part of data structure revision. Yes. Okay, welcome back to you too. If you haven't liked the session, please session को like कर दो यार. Session को like कर दीजिए. चलो start करें tree से. What is the tree? Tree is nonlinear data structure in which we have nodes and edges. It is always having n nodes. If n nodes, n minus 1 edges. The nodes start from the root. क्या हुआ? Root. Always starts from the root. The very first node is named as root. Now we have each node maybe having children. Children means 2 ka children, 5, 7 and so on. 7 and 5 are having parent as 2. So this is fine. This is fine. Parent is fine. Sibling are, these two nodes are sibling of each other just because having the same parent. Siblings of each other. There is no any sibling of 9 just because no any other child of 5. Subtree. A node starting from a node, entire tree downside is called as subtree. Starting from 7 is root. Like that way you can form so many subtrees. Internal node, such kind of node which is having some child, at least one. Any node which is not having any child called as external node. We know that total number of nodes in the tree is equal to total number of leaf nodes plus total number of non-leaf nodes. Level number in the tree starts from 0. Next level 1, 2, and so on. The level starts growing. The lowest level is this, which is the largest level number always. Chali. Next is height of a tree. Height of a tree can be defined in two ways, either single node height 0 or single node height 1. Single node height 0 means empty tree minus 1. Single node height 1 means empty tree 0. Single node height can be given as the maximum level number also, or the number of edges in the path, or distance in the path from root to the farthest leaf node. Here other one, if maximum level number plus 1 or single node height is 1, then maximum level number plus 1 is the height of the tree. That can be given as number of nodes in the path from root to the farthest leaf node. Height key definition will be mentioned always in the question. Consider that whatever is given always, otherwise you may get wrong answer. Height of a tree. If you are going with the binary tree, we calculate height of a tree like that way. If empty tree, height we will return 0 or minus 1, depends. It may be 0, it may be minus 1, depends what kind of definition you are implementing. If height is not, or tree is not empty, just calculate height of the left subtree in Excel recursively, height of the right subtree in XR recursively. Whichever is greater plus 1 will be the returned height. If XL is greater, XL plus 1, else XR plus 1 will be returned as the height. Then we have a binary tree. Binary tree means a tree which has maximum 2 children, minimum 0. In the binary tree, how to get or how to detect a leaf node? For that, we need to know the linked representation of binary tree. How to represent a binary tree into linked representation? So we'll be having the nodes in such a way. We'll be having the key here. Here we'll be having left child pointer. Here we'll be having right child pointer. What will be the structure of linked representation for each node? Struct binary tree node. 3 values are there on each node. First of all, let's say character type of data. After that, you'll be having 2 pointers. Struct BT type or BT node type pointer. Pointer name you can have as left child, and another binary tree node type pointer which is right child. Name of the pointers may vary. Complete left child you can write, complete right child also you can write. If a pointer is pointing to the node and node is leaf node, the condition will be very simple. Pointer ka left child is equal to null and pointer ka right child also equal to null. This is the condition to detect if pointer P is pointing to the leaf node or not. Next thing is this handshaking lemma. In the binary tree, we know that total number of leaf nodes are equal to internal nodes with 2 children plus 1. Remember, this we have written in such a way: internal node with 2 children plus 1. Total number of internal nodes are internal node with 1 child plus internal node with 2 children. So total number of nodes will be equal to total number of leaf nodes plus total number of internal nodes, which leads us to have n is equal to twice of internal node with 2 children plus internal node with 1 child plus 1. In this type of questions, you may have degree. In the binary tree, in general, degree is nothing but number of children of a node. Then we have seen such kind of question: how many binary trees can be constructed using n unlabeled nodes? Unlabeled means the nodes which are not having any kind of key or labeling. For that, we must have this as equal to Catalan number. This. And if we are given that n distinct keys are there and you'll have to construct binary trees, how many these kind of unlabeled tree we can have? And each unlabeled tree can be populated with n factorial way of keys. So this is the answer. Binary tree representation of general tree. So this particular binary tree representation of general tree is called as leftmost child right sibling representation. Remember, if this is the tree, how to do that? A is root. A is having the leftmost, first child from the left side should be in the left. Sibling of A in the right, nothing is there. B ka sibling C, C ka sibling D, D ka sibling E. In the sequence from left to right, I have kept B ka right C, C ka right sibling D, D ka right sibling E. Now for B, is there any child of B? No, nothing is in the left. Is there any child of C? Yes. So left of C should be the first child, which is F. F ka sibling G, G ka sibling H. Now we do have children of D, no left empty, E left empty, no F left empty, G nothing, H ka child, first child should be in the left, I ka child, first child in the left. There is no any sibling of I, that's why I ka right empty. Good, good, good. How to detect the leaf node? If any pointer is pointing to a leaf node, detect the leaf node, pointer ka left most child should be null. Just because all the children are in the left only. If pointer ka left most child is equal to null, means P points to a leaf node. Just because in the right side though, we don't keep the children here, we keep the siblings. P points to पत्ता नोड, लीफ नोड. चलिए आगे बढ़ते हैं. अगला प्रश्न ये रहा आपके स्क्रीन पर. मैक्सिमम एंड मिनिमम नंबर ऑफ नोड्स इन अ बाइनरी ट्री विद हाइट h. Height of a tree with single node is equal to 0. Okay, so minimum you will be having h plus 1. Maximum you will be having is equal to 2 power h plus 1 minus 1. Reverse height should be equal to almost h or n minus 1, and maximum height and minimum height you will be having around log n. Chalo, minimum and maximum number of nodes in a binary tree on any level, which is 2 power L. Level number 0 is 1, level number 1 is 2, level number 2 is having total number of nodes 4 and so on. ये सब देखा हुआ है हमने. ये सब everything we have seen. Traversal. 3 type of traversals are there. Pre-order traversal says first node, left subtree, then right subtree recursively. Then in order, left subtree recursively, then node and right subtree recursively, same to same manner. Post order, first of all left subtree, then right subtree, then node. For that, we have seen the methods, 2 types of method. You remember dot method first is very important to remember. What is the dot method? If we have pre-order general one, then put the dot in the left side before left to right for each node and start the traversing from left to right, like we don't leave the boundary. And answer will be A, B, C, D, E, F. If you want to go for in order traversal, put the dot in between left and right subtree. After left, before right subtree, and traverse from left to right. You all must remember these algorithms also. What is the answer? C, B, A, E, D, F. And for post order traversal, put the dots after both of the left and right subtree for each node and traverse from left to right. What is the traversal? C, B, E, F, D, and A. C, B, E, F, D, A. There are 3 types of more traversals we had. These traversals are converse order traversal, means we are traversing the left subtree, no, right subtree first. So pre-order converse type, node first, but after that right subtree and then left subtree. Converse in order, right subtree, then node, then left subtree. Post order, right subtree, left subtree, and the node. In that case, converse pre-order, where you put the dot in the right side, just because from the right side we are starting the traversal before right and left together. Traversal sequence should be from right to left. Do not leave the boundary, remember, okay? Answer will be A, D, F, E, B, and C. For in order traversal, put the dot in center only before right subtree, after right subtree, before left subtree, but the traversal should be from right to left. That is the difference here, okay? Remember. F, D, E, A, B, C. And one last. Post order traversal. After right and left, both the subtrees here. Put the dot and traverse from right to left. And the traversal will be F, E, D, C, B. And these are the 3 observations. First of all, reverse of converse pre-order is general post-order, reverse of converse post-order is general pre-order, and reverse of converse in-order is in-order only. Vice versa is also true, but 2 more observations we should have from here. Whichever the traversal you take, converse or normal, last symbol of post-order is always root. Similarly, first symbol of pre-order traversal is always root. We will utilize this concept to draw the tree. Okay, I have written over here construction of a tree. In general, we will require minimum 2 traversal. One should be in order traversal to construct unique tree always. So can pre-order and post-order give us a unique tree? Yes, only when you have each node with two children. If each node has two children, then yes, pre-order, post-order together can give you the each and every node is having two children, otherwise leaf node, then yes, pre-order, post-order can give you the unique tree. How to draw? It is very simple. First node is root, pre-order traversal, then check out in-order traversal for left and right. Before 1, you are traversing 2 and 3. After 1, you are traversing 5, 4, 6. So 5, 4, 6 in the right. This is in the left. For left, just check out what is the root 2. After 2, you are traversing 3 in the in-order traversal later. So right side. For 4, 5, 4, 6, check out pre-order traversal for root. Root before root in order traversal, you are traversing left and right. After root, this is the tree. Construction of tree with the post order in order. In the post order, last symbol is root. A is root, left and right. For the left, look at this. Last symbol is B, root, E left, F right from the in order traversal. Here, D, G, C. C is the last one, root. Okay, fine. Before C, both the D and G traverse in order traversal means left. Left, D is first, last, D root, and in the right, G from the in order traversal. So post order and pre order you will use for identifying the root. In order you will use to identify the left and right child. Good. Complete binary tree. It says that complete binary tree says every level should have the maximum nodes except possibly the last. Last node shows that last level says that last level can have lesser than maximum nodes but should be arranged from left to right. All the nodes should be arranged from left to right. That is a complete binary tree. Remember that? Okay. Now, if you are having a complete binary tree, in the complete binary tree, maximum and minimum, how many nodes you can have of height h? H 0 with single node. Maximum is same to same. 2 power h plus 1 minus 1. Minimum is how many? Minimum is 2 power h. Why? Just because if you want to have minimum nodes, last level should have only single node. This one. That's it. 2 power h. Oh, sorry. Height is h. 2 power h is the minimum number of nodes. Good. Any array representation? Oh, sorry. Array representation of CBT. How to have array representation of complete binary tree? Array representation of complete binary tree says that root is stored on index number 1. After that, for any node at index I, left child should be on 2i, right child should be on 2i plus 1. And parent should be on I by 2 lower value. That's it. So if a complete binary tree we have like this way, it will be stored in the array like this way. A on index number 1, C, B, F, G, D, E, H. You remember, right? That you just write from left to right the level order traversal on the sequential indexes, and it will represent the array representation of the tree. But we use the CBT only to be represented by array just because it has all the elements completely full. If you will have general binary tree, we cannot use it just because the n number of elements may require 2 power n size of array, just because it might possible that array will be having, or the tree can have this particular n nodes or 4 nodes. For that 15 size of array is required to be stored, right? That is why we don't use the general array to be, or general tree, binary tree to be stored in this. CBT is there. Chalo. अगर 0 से स्टार्ट होगा तो -1 कर लो सब में. यस, करेक्ट. Full binary tree. Full binary tree says that, sometimes called as strict binary tree or proper binary tree or 2 tree or 2T. It says that it will have each node either 0 child or 2 children. Every node having 0 child or 2 children. In that particular case, when we say total number of leaf nodes, it will be total number of internal nodes plus 1, just because each internal node having 2 child. There is no any internal node with the single child at all. In such case, total number of nodes will become 2i plus 1 or 2l minus 1. Hence, always the n value will be odd. Total number of nodes will be always odd if you have any full binary tree. K tree says that each node, let's say, having either 0 child or k children. In that particular case, total number of leaf nodes will be equal to k minus 1 into total number of internal nodes plus 1. Look at this. For binary, 1 into 1, I plus 1. For 3-array tree, it will be 2 into I plus 1. So for k-array, k minus 1, I plus 1. Good. Left skewed binary tree. Each node has only left child if it is having child. Every internal node having left child. Right skewed binary tree. Every internal node has only right child. Right skewed binary tree. Expression tree. ये वाला expression है ना? The expression tree means you are representing expression on the tree. It says that the operator will be on the root. The left operand will be on the left child and right operand will be on the right child. Good. Nice. Expression tree. For expression tree, we will have to consider what? The precedence and associativity of the operators. Sure. So expression tree precedence is what? First of all, multiplication, no division, no exponent. Yes. So first of all, exponent 3, exponent 2. Operator, left operand, right operand. This is done. This result, multiplication with 7. Multiplication, left operand 7, right operand this. This result divide by 4. And this result plus 2. This is the complete expression tree. Good, good, good. Nice. Draw the tree. करके देखो practice जल्दी से. Operand always on the leaf node? Yes. Operators always on the internal node. Minus b. Minus and b. Log of x. Log operator x. X factorial. Factorial is the operator. Left operand x. Log of x factorial. First of all, factorial x and log of that. That is the tree. BST, binary search tree. Easiest possible manner. Binary search tree is that particular tree. For every internal node, left subtree should have smaller values, right subtree should have greater values. Okay, so for every node, left subtree should have all the entire left subtree should have lesser values, right subtree should have greater values. That is the binary search tree. Fine. In the binary search tree, how to search an element? If we are on the root, from here, if we check, if the element is smaller, go towards left. If element is greater, go towards right, and keep doing that until you reach to the element. When you reach to the element, fine. If you don't reach to the element and if you find that there is no any element further in the left or right, then you can say that it's unsuccessful search. How can I make here? You just make in your mind and tell me that, sir, I got the same answer. Okay, no problem. I'll understand that you are sincere here. Chalo. How to identify valid or invalid search sequences in the binary search tree? Simple it is. If we are searching 80 in this particular example, it's very simple that we'll have to understand that to search 80 we will go towards left or right. If we are going towards left, from current element every value should be lesser after this. If from current element we are going towards right, so every value after the current element should be greater than the current element. That's it. You'll have to follow. Look at this. From 9, if you are searching 80, you'll go towards right just because 80 is greater than 9. So every value after 9 should be greater. Why? Just because from 9 you are going towards right to search 80. So every value encountered should be greater than 9. Yes, it is. 120. From 120, 80 is lesser. Go towards left. Every value should be lesser than 120. No problem. Then 12. From 12, every value should be greater just because 80 is greater. No problem. From 58, 80 is greater. Go towards right. Means every value should be greater than 58. Oh, no, it is not. 50 is in the right of 58. How is it possible? Not possible means it is wrong. Similarly, you can find out other sequences. If everything is correct till the last, means sequence is correct. If such kind of mistake happens, that we will go towards right, but smaller key is encountered in the right, or we are going towards left and larger key is encountered in the left, then wrong. You can easily search which one is correct, which one is. No, it's fine. अरे हम भी मजे ले रहे हैं. रूपम, कोई प्रॉब्लम नहीं है, it's fine. Totally fine. Finding minimum in BST. How to find minimum in binary search tree? From root, go towards left and left and left and left. The leftmost node whose left child is not present will contain the minimum. This node can have right child? Yes, but it should not have the left child. Fine. Cool. That's how you can find the minimum. It can be a leaf node. It can be having a right child, but it will not have the left child. Fine. And similarly, finding maximum in BST, you will go towards the right, from root to right, to right, to right, until you find a node whose right child is null. Right child is null, left child can be null, cannot be null, I don't care. Right child is null for this node means it is containing the maximum value. सर्चिंग में एलिमेंट मिल भी नहीं सकता है, ठीक है, मिलेगा नहीं मिलेगा वो हमारा आउटलुक नहीं है, मिलेगा नहीं मिलेगा डज नॉट मैटर, सीक्वेंस करेक्ट है या नहीं ये बताना है बस इस टाइप के क्वेश्चन में. चलिए, अगर हमें इफ वी विल हैव टू इंसर्ट द एलिमेंट इन द गिवन ऑर्डर, व्हाट टू डू? We'll have to go with the one by one insertion. How to do that? 18 on the root, 5 left side of 18. Why? Just because lesser. 8. Always try to search from root. Where should I insert? Left ka right. 19 in the right. 20 in the right. 35 in the right. Greater. Then 23. Greater, 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 and 23 here. Then 9. Lesser, greater, and greater. 11 lesser, greater, greater, greater. 16 lesser, greater, greater, greater. 1 3 lesser, lesser, greater. 25 greater, 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 lesser, greater. 25 here. Like this way you can construct the tree. Always check from the root where to insert the element. Then we have seen deletion in BST, which were never ever used in any of the GATE question till date. Never ever. So let's skip this, but let's quickly discuss how to delete a node from BST. Zero child, if a node is having, just directly delete it. If single node is having a single child, a node is having, then attach that child to the grandparent. Means in the place of node, current deleted node, you just put the single child. If two children are there, replace the node by either in order successor or in order predecessor. Remember that point? Sure. Insertion. Okay. Complexity. In binary search tree, when we go for searching, insertion, or deletion, complexity is big O of h. H is what? Height of the tree. In the best or average case, it becomes log n. And let me put it as capital H. Difference समझ में आएगा आप लोगों को. And in the worst case, it becomes n just because the tree can be skewed kind of, or single node unbalanced tree also. single node on each level, unbalanced tree we can have. So for the balancing, we'll go for the AVL tree. है ना? In order BST. Always a sorted sequence in ascending order. Okay. Sure. Question. Pre-order. If pre-order is given and you will have to construct the tree, you don't have to get the in order and draw the tree with in order and pre-order like that way. You just insert from left to right and that's it. Insert the keys from left to right with the given pre-order traversal and you can draw the tree. 15, 10 inserted, 5 inserted, 9 inserted, 12 inserted, 19 inserted, 16 inserted. This is the tree exactly which is having same pre-order traversal for sure, 100%. If post-order traversal is given, then you will have to insert the keys from right to left. Right to left, insert the keys, then you can get the tree easily. 15, 18, 20, 17, 6, 7, 13, 9, 3, 4, and 2. This is the tree. Yes. Number of BSTs using n distinct keys is Catalan number. Such kind of questions, you remember how to answer such kind of questions? When searching for a key value 16, a BST, how to answer such kind of questions? याद है आप लोगों को? We have seen that. So we'll divide. We are searching 60. We'll divide it into two parts: smaller values, greater values. This is four values. These are 3 values. Total 7 values. So 7 factorial divided by smaller values factorial into greater values factorial. Such kind of question we have seen, right? AVL tree. AVL tree says that it's a self-balancing BST, means that it will always have balance factor for each node between this range 0, 1 and -1. What is the balance factor? Height of the left subtree minus height of the right subtree for each of the node. Imbalancing can be of 4 types: LL, RR, LR or RL. This again doesn't come in the GATE exam much, never ever have been asked, so I am skipping this right now. Just check out this, that how many minimum number of nodes we can have in the AVL tree with height h. This is important. ये important है, ये कर लेते हैं. कैसे minimum number of nodes in AVL tree with height h you will calculate with single node height 0. So for that we have seen a specific formula. Remember, if we have to calculate minimum number of nodes with height h, it is equal to number of nodes 1 when height h is equal to 0. For height h is equal to 1, it is 2. For height h greater than 1, we need to have one side minimum number of nodes 3 with height h minus 1 plus other side minimum number of node height 3 with height h minus 2 plus 1. That's how you can do it. Yes, one by one. This year no question from tree. BST से क्वेश्चन आया था एक, इस साल भी आया था एक BST से क्वेश्चन, बाइनरी सर्च ट्री का, थर्ड लास्ट और थर्ड मैक्सिमम they have asked. Then we have seen heap. Heap is having 2 properties satisfied. One property is it should be a complete binary tree. Second property is max heap or min heap property. Means if it is a max heap, then every value should be greater than both of its children. Every node should be having greater values than both of its children. If it is min heap, then every node should have minimum value or lesser value than both of its children. And it applies for all the nodes. If we have max heap, the root is having maximum value. Min heap, root is having minimum value. For max heap, to get the maximum value, you will need constant time just because it is on the root. For min heap, if you want to get minimum value, it is on the root. But if it is max heap and you want to get minimum value, you will have to have theta of n complexity. Traversal is required just because it will be always present on the leaf node. The minimum value on the max heap will be always on the leaf node. Similarly, in min heap, the maximum value, if you will have to search, then it will be always on the leaf node and it will take theta of n runtime complexity. Searching in the heap also requires theta of n just because there is no any a pattern that the element should be here or there, lesser only left or greater only right, like that way, no pattern. So you'll have to search an element in the traversal or through the traversal only. That's why searching in the heap requires big O of n complexity. Array representation of heap, we have already seen that it is same as complete binary tree. Insertion in the heap. If we want to have the insertion in the heap, let's say we have a max heap example. And in this heap, you will have to insert an element, let's say 8. What you will do? First of all, you will insert the element based on the complete binary tree. For complete binary tree, I'll have to add another node. I'll have to add another node in the right of 6 here. So first add the new element based on the complete binary tree. After that, adjust. How I should adjust? I'll have to check that 8 ka parent is greater than 8 or not. 6 is greater than 8? No. I'll have to switch it. 8 will come up just because 8 is greater. I'll have to check again 8 is greater or its parent 8 ka parent 15 is greater than 8. Yes, no problem at all. So what I will do, I will just adjust the tree after the insertion. Let's say after this, I am inserting another element which is 21. So if you insert 21 based on the complete binary tree definition, 21 should be inserted on the next level left of 7. After that, I'll check 7 is greater than 21. No, max heap property is not satisfied. Switch 21, 9. 9 is greater than 21. No, 21 comes up. Then 15, 21. 15 is not greater than. So we'll switch. So the tree will become like this way: 21, 15, 8, 9, 2, 4, 6, and 7. So first, based on the complete binary tree insertion, insert the node, and after that adjust. It may require big O of log n just because you may have to switch or interchange till the root. Sure. Building a heap, one by one insertion. Let's say we are building a min heap and we will have to have one by one insertion. What to do? Root first, then 10 here. Min heap property satisfied, yes, then insertion of 3. Min heap property satisfied, no, 3 will go up, 4 will come down. So the tree is like this way. After that, insertion of 5. Min heap property satisfied, no, 5 will go up and 10 will go down. After that, 1. So 1 will go up and up. It will be here. 5 exchange with 3 or 1. It will be like that way. Min heap property like this way. Yes, Akib. There is another method to build a heap which is heapify. It says that you just construct with the given keys a complete binary tree first. No any one by one insertion. Just insert it in the sequence from left to right as a complete binary tree definition. 15 and 17. 3, 5, 4, 6, 13, 1, 10, 9, 8, 15, 17. After that, you just adjust starting from the last internal node. Last internal node is 13. Adjust the tree based on it. Whatever the tree you want to have, min heap or max heap. Let's say I am trying to have min heap. मीन हीप में तो एडजस्टमेंट ज्यादा लगेंगे नहीं. Let's try to have max heap. So last this one internal node from here 15 and 17. 13 is greater than both of its children? No. So among both of its children, maximum value will go up. 17 goes up and 13 will be interchanged to here. Similarly, 6 is greater than both of its children? No. So adjust it. 6 will go down, maximum of the children will come up. For 4 is greater than both of its children? No. So maximum of the children will go up, 4 will come down. For 5 we will adjust, maximum of the children will go up, 17 here, 5 down, but 5 is still not greater than both of its children. So 15 will be up and 5 will be down. Similarly, 3 is greater than both of its children? No. So 3 will come down here and 15 will come up here and 13 will come up here. So the tree will become 17. Right side 10, 1 and 4, no problem. Here we'll be having 15, 9, 6 and 8 for 15. Okay, 13 will climb up and 5 here and 3 here. This will be the tree. If we go for one by one insertion, n number of keys, then n log n will be the runtime complexity. But if we build a heap with heapify, it will take only n time, just because we don't have to perform n number of operations log n time, or log n operations n time here. Deletion in the heap says that first of all delete root, just because highest priority element it is, minimum or maximum. Okay, remove last node from CBT, complete binary tree, and place it on root. So we'll remove the last node on the root, and after that we will heapify from root. So from single root only you'll have to heapify, just because for the root, after placing, look at this, this is the left subtree, this is the right subtree. First of all, root deleted, then last element of the complete binary tree you will remove from here and place it on the root. Its left subtree is already a heap, right subtree is already a heap. Just heapify from the root and it will take log of n base 2 times maximum. That is the deletion method. Number of heaps with n distinct keys is this one. It is a combination n minus 1 combination k into t of k into t of n minus k minus 1. It's a recursive formula for t of n. And what is k value here? K is nothing but number of nodes in the left subtree. How many? With n given, you can easily draw the complete binary tree and you can check out that from the root how many left subtree nodes are there. Number of nodes on left subtree of root. And after that you can calculate this with t of 1, t of 2, t of 3, t of 4, t of 5, t of 6 and so on. Sure. Then we have seen hashing. Hashing says that searching technique which can provide result in constant time. In this we have a hash function which provides us value of L, which is the location. What is the location? We'll have a hash table in which we'll be having a range of locations. While inserting, we will apply the hash function. We will store the key at the hash table on that location. While searching, we'll do the same thing. Hashing technique. Maximum time we'll be using the division method only. Division method says that h of k is equal to k modulus, which is the percentage operator by m. That's it. K. Can somebody tell me what will be the answer of these one? Hash functions are given. You need to give me the locations. K mod 10, 228, 8. K mod 11 is again 8. K mod 6, 6 18 बचे 4 48 0. K minus 5, 223. Situation that occurs when two distinct keys have the same hash value location. So first key can be inserted like this way, K percentage of 10, K mod 10, 12 we can insert at 2, but 52 will generate the location 2 only. It is preoccupied, yes, called as collision. If a key generates a location which is already occupied, we'll have to try to generate another location, or somehow we'll have to store that 52. Why? Just because there is a collision on that location. Collision can be resolved using these techniques, collision resolution techniques. How to do that? 4 methods in open addressing or closed hashing, 1 method in closed addressing or open hashing. Open addressing means if one address is having collision, all the addresses are open to be generated using these methods. And closed addressing means if one address generated, on that address only store all the elements. Closed hashing, just because number of keys total can be stored is equal to number of slots. Here number of keys can be stored more than number of locations, just because we are having the chain or linked list. Linear probing says that if we are generating a location L using a hash function and there is a collision at L, then generate new location L dash by adding in the original location I, but keep it in the range by modulus by size. And what is I? Initially you will add 1, then 2, then 3, then 4, then 5, then 6. In the original location plus 1, then plus 2, plus 3, keep going with that. Quadratic probing says that when you are generating location L by a hash function h of k and there is a collision at L, then you are going to generate another location L dash by original location plus I square mod size of the table, so that the plus I square will always be in the limit. I square, I is initially 1, then 2, then 3, then 4, then 5, then 6, then 7, keep going. Yes. Random probing says that you are getting location from h of k and there is a collision at L. Then only you generate the next location by adding into R, initially R, then plus R, and plus R means in the original location initially R, then 2R, then 3R, then 4R, and so on. Mod size of the table. Initially I is equal to 1, then 2, then 3, then 4, then 5. Then keep going with this. How you will get the R? R is a random number that will be given in the question. Double hashing says that you are calculating h of k, generating L. If there is a collision at L, you are doing the same thing. You are generating another location L dash by adding I into R on the L by mod size. But how do you get L this time or R this time? This R you will be getting by another hash function this time on the same key K. That's the only difference from the random probing. Double hashing says you are going to have another hash function to generate R. Then we have a chaining. Chaining says that all the keys which are inserted on the single location should be in the linked list. 12, 52, 92, 2, all the values which are mapping on the same location should be stored in a linked list instead of the same bucket. Hence, you will be having unlimited number of keys to be inserted. No any overflow problem you will be having here. Chaining, simple. Hash function, hash table never fills up, less sensitive to hash function, and it is mostly used when the hash function and the upcoming keys are not known. Like what kind of keys are there, how many keys will come. If it is not known, you can use this chaining. Disadvantages: cache performance is poor just because we need the consecutive locations or the spatial locality of reference for a better cache performance. It is not there just because of the linked list. Wastage of space, because lots of new locations or lots of locations may not be filled up at all or may not be used. Of course, link part is again another overhead just because we are storing lots of addresses. Those are extra spaces required in the chain. When the chain becomes long, search time may become big of n. Clustering. Clustering means if we have so many keys in a single space together on the consecutive locations, another key is coming and it is inserted around that particular cluster only or that particular sequence only, means making that sequence even more longer. That is primary clustering. If this clustering is done on two different places or multiple different places, called as secondary clustering. Then we have seen the load factor, average number of keys per slot. Formula is simple: number of total keys inserted divided by total number of slots. Then space utilization, how much percentage of space utilization we have, which is equal to total occupied slots divided by total number of slots. Perfect hashing says that you are going to have n number of keys and n number of slots. Keys inserted, n keys to n slots without any collision. That is perfect hashing. Minimal perfect hashing, let's say you have n number of keys but only m number of slots, and here m is lesser than n. Number of keys are so many, slots are less. So for first m keys, there must be no collision, and for remaining, how many? N minus m keys, there will be collision for each, and that is called as minimal perfect hashing. Then we have called one more thing which is called as uniform hashing. Uniform hashing is nothing but that we are having a hash function in such a way that it can generate all the locations uniformly. All the locations means it is able to generate all the location, whatever the key, depends on of course the key, but it can generate all the keys or all the locations. Some of the hash functions are faulty, which are not uniform hashing, means it may generate a few of the locations but it will not be able to generate all the locations, and hence it is the faulty one. आप एल्गोरिथम पढ़ाओगे? नहीं बेटा, हम नहीं पढ़ाएंगे, आपको अनअकैडमी प्लस पे आना पड़ेगा और वहां पे आपको मिलेंगे बेस्ट एजुकेटर, आपको एल्गोरिथम के मिलेंगे जिनका नाम है सुब्बाराव रेड्डी सर. Okay, so it is done. Some 2 hours 15 minutes, entire data structure, quick revision done. Yes, good. Telegram channel, you join this one so that you can know what are the locations or whatever the classes I'm going to have, their links, announcements, plans, etc. 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 BFS DFS छूट गया यार, इसमें आया नहीं, वो तो रह गया, कोई बात नहीं. You can revise it by yourself. Anybody who is here and want to have the best out of me, want to have my maximum hard work utilized for you, join on Unacademy Plus or Iconic. Just because I do have my hardest possible work only for the Plus members. I do work here, yes, but you can see if I am putting this much of efforts for YouTube students, how much efforts I should put for the Plus members. You guys are having data structure classes at 6 p.m. daily now onwards. You can see lots of different plans are available for Unacademy Plus and Iconic. You feel like, okay, if I'm learning from YouTube, I am understanding everything. But when you solve the GATE question, you will understand that understanding everything will not help you only cracking the gate. You will have to understand one particular method. You'll have to crack one particular method, which is how to utilize the knowledge to solve the problems. And that particular thing you will learn in a very structured and organized manner. Use this code VDEEP10 to unlock 10% instant discount plus this offer. Offer is if you take 24-month subscription, 4-month extra, 12-month subscription, 3-month extra. After the gate, you will certainly go with the other exams and other interview preparation. For that, you will need the subscription. Keep the subscription for extended period. This offer is up to only 24th of March. And look at this, these prices are going to increase soon. You can check out my course COA is starting from 23rd of March, and you can see new batch is also starting. So access that particular course from the best of the possible manner. Look at this, the price hike will be this much after the few days. Take the subscription. Code VDEEP10. Remember the code. Look at this, these are the classroom students who were there last year. GATE rank 1, GATE rank 4, and there are so many classroom students we have who have got really good rank this year. Chaliye. We have a test series also called as Unacademy Lite. In that you can learn or you can get only test of Unacademy platform test series. Using this code you can get 10% discount. This one also. Name of the test series is Unacademy Lite. Every weekend we conduct the scholarship test also. But if you can't crack the scholarship test, take the subscription directly. But do not wait for any miracle to happen, just because you will have to do the miracle by yourself with your hard work. Thank you so much for listening out this. If you haven't liked the session, like it, share it, subscribe the channel, turn on the notification so that you don't miss any of the session. See you in the next session at 6 p.m. Till then, have a great day. Happy learning. Bye-bye.